Okay, today I'm going to show you how to set the bias on a Carvin Vintage 16 amplifier. And I've got a chassis here from a Vintage 16 sitting up on my bench. And first thing we want to do is check the voltage. We want to know what the voltage to the plates is. So I've got a digital multimeter here connected. I've got it set to read volts in DC, so DC volts. I've got the black lead connected to using a alligator clip here to connect the black probe to a bolt for the power transformer. That gives me a good chassis ground. And with the red lead, I'm just going to touch the connector here for the plate voltage on one of the power tubes right here. And if we look up at the meter, we're showing 345 volts. Okay, so we'll just want to record that somewhere, and we're going to use that later when we check the current next. Okay, 345 volts at the plates. Okay, next, in order to measure the current, Carvin actually has this set up pretty neat for you to do that. First thing we want to do is make sure we turn it off. We don't want power flowing through the amp now while we're going to do this next procedure. And it's not a bad idea to wait a little bit of a time, give it 5 minutes or more to sit, and let those capacitors drain. But we're not going to touch anything with our hands anyways, just to be safe. So what we want to do here is we've got the B plus going to the center of the center tap of the output transformer is right here at QC2. What we want to do with some insulated pliers is take a hold of that and gently rock it back and forth till you can remove it, and move it over to this other connector right next to it. I think that is a QC9. Yep, okay. So now actually that connector is not connected to anything on the PCB. That's just a dummy connector, a place for you to set that. Alright, now what we want to do next is set our meter up to read current and connect the probes to those two terminals, and I'll show you that in just a minute. Okay, I've got the meter now set to read current, DC current, and I've got it set to the 200 milliamp range. That's plenty for this little amplifier. Then on my connections, I've got the black lead connected using, again, an alligator type insulated clip here, so I don't have to be touching anything or holding any probes with my hands. We're going to use clip to do that for us, so there's no slippage. Now I'm going to take the other one or another slip-on, and I like to use these slip-on type connectors because I'm just going to put this one on by itself on this other terminal, and this terminal is live once there's power to the amp. Right now the amp is off, so there's no power going to it. But I'm just going to attach that with, now you see there's no lead actually there. What I'm going to do is turn on the power next, and we're going to let the tubes warm up a little bit, but they don't have to be fully operational at this point. What we're going to do now is just insert this probe into that after the amp is already turned on. And if we look over at the meter, we can see the current start to come up. See that? Now, the reason I connected that lead to my meter after the amp was turned on was to prevent the fuse in my meter from blowing due to the inrush current. Very often that's what will happen. There's a surge of current through the amp to allow the capacitors to charge up when you turn the amp on, and often that inrush of current will cause the meter to the fuse in the meter to blow. Alright, so now we can see once that meter is settling down at just about 63 to 64 milliamps. Alright, and if you recall, the plate voltage that we had recorded earlier was 345 volts. Alright, so now we need to do a little math. Okay, so I've done a little math here. What we've got, first of all, we have a pair of EL84 tubes. And EL84s are rated at 12 watts max dissipation. Okay, that means we don't want any more than 12 watts of power being dissipated across the plates of those individual tubes. 12 watts each. That's maximum, but we don't want to run at maximum dissipation, or we'll burn those tubes up, because as soon as we start playing, the current is going to increase. So we want to hold that down to below. A good rule of thumb that seems to be used a lot is 70%. Let's not go above 70% to keep those tubes cool enough that we won't wear them out too quickly. So that's about 12 watts times 70% is 8.4. 8.4 watts is what we want to stay below. And since we've got two tubes, that's 8.4 times 2 is 16.8 watts maximum. Alright, so right now we've got a plate voltage of 345 volts DC times a current of 64 milliamps, so that's a 0.064. That equals 22 watts. That's too hot. We got to cool this puppy down. Alright, so what are we going to cool it down to? Well, Carvin recommends 40 milliamps. That's really not too bad of a number. What I've done here is we've got 16.8 watts is the 70% rate for two of these EL84s. If we divide that by the plate voltage 345, we get a number of 0.048. So we could come down to 0.048 milliamps. But when we do that, probably our plate voltage is going to go up a little bit, and then we're right at the 70% rating anyway. So let's tell you what, let's turn that down to 45 milliamps, and then let's check our plate voltage and see where we're at. All right.